Hello. What follows is basic factoring of binomials. Binomials are any expressions that have two terms. The terms are separated by a plus or minus. So this is a binomial because it's 5x subtract 20. This term is 6x squared y, and then the other term is 4y. So this is a two-term expression, separated by subtraction. So that's a binomial. Factoring binomials is simply a matter of finding out what was distributed. In other words, this is the reverse distributive property. So in other words, there was a binomial, somebody distributed something into it, let's take out whatever was distributed. Another way to look at it is it's looking for common factors. So the way that I do this in my head, and I would like you to write this out this way, is I break up the two terms, 5x and 20, into factored form where I'm looking for seeking factors in common. So the first term has a 5 factor and the second term has a 5 factor. So that's the common factor. That's the magic number that was distributed. Now all I have to do is take that 5 out, undistributed if you will, and you can see here that if I were to redistribute it, I have 5x minus 20. So factoring binomials is essentially the same as reverse distribution. Now checking is the same way. We find a value for x, any value we want, except try to avoid 1 and 0, and we put that number into the original expression. So that's when I say let x equal 3, I go down here and write a. Here's the original expression where x was 3. I'd like you to notice I put 3 in parentheses. Wherever x used to be, I put in a new number with parentheses, so that way we know that's where the new number was put in place of x, or substituted. That's 15 minus 20, which is negative 5. Then I go to b, which is my simplified result. We have 5 times the quantity, 3 minus 4 instead of x minus 4. And inside the parentheses is 3 minus 4 is negative 1. 5 times negative 1 is negative 5, which means I got this right. You can also put each expression, the given and your result, into Desmos and verify that they produce the same graph. Remember, this is what you'll use if we have a non-calculator test to check your answers, and this is what you'll use for homework to check your answers in a more efficient and reliable way. Factoring binomials doesn't have to be, or it can be, it can get more complicated. Here, there's more than just numerical factors. There's also variable factors that are in common between both terms of this expression. So what I'm going to do is write the factors. See, I've got 6, which is 2 times 3. I've got x squared, which is x times x. I just left it as x squared. And we've got y. And the other term is 2 times y. That's what 4y is. So I observe what's in common. Each term has a 2 factor and a y factor. So I am going to take out a 2y factor from each of these terms and undistribute it. So that way we get the factored form of this binomial expression. Check the same way. And of course use Desmos as well. Now the tricky thing about Desmos is it treats x and y as variables, and it's going to try to produce a graph. If we put an xy expression into Desmos, it's not going to be able to work for us. So what I did was I changed x and y into a and b, and then Desmos prompted me to add sliders for a and b, so I did, and then I made x equals 3 and y equals 4. I made a equals 3 and b equals 4 to verify that I get the same number from both expressions. A quick reminder, I don't think that this stuff is so difficult that it has to be checked. That's not why we're checking. We're checking because that is a habit that we need to get ourselves into. So you should never be satisfied with a problem until you've proven that you've actually done it right. So keep that in mind as you do your work. Thanks for watching. Have a good day.